Good morning, girls. We will continue the same chapter, that is force and laws of motion. And children, we have come to the last topic of the chapter, right? And today we are going to study what is the law of conservation of momentum. Okay. Now, you must be remembering that in the previous weeks we have done what is force, what are the different effects of force, what are the different forces like balanced and unbalanced forces also I have taught you. Then we did what is the first law, we did what is inertia, second law, momentum, second law, and the third law of motion. Right now, today we are going to study what is the meaning of or what is the statement of the law of conservation of momentum, and I will explain you with a particular example. Now, law of conservation of momentum. You all know what is momentum? Momentum is given by mass into velocity, right? The product of mass and velocity is momentum. We can also say that momentum is the quantity of motion present which is present in an object. So any object which is in motion will have momentum, and the object which is not moving or it is not in motion, it will have zero momentum, right? Now, to understand this law of conservation of momentum, you have to remember a few points, so which I am going to tell you now, and then we'll come up to the statement of this law. See, the law of conservation of momentum says that I'll take up two objects. These are the two objects, right? These are the two objects which I take. Now it says that when any two objects, right, collide with each other or they interact with each other, what happens? One object loses momentum and the other object gains momentum. Okay. Now, suppose this is a truck and this is a car. Okay. Now, when they collide, when these objects or when these two vehicles collide with each other, they will interact with each other, right? What will happen? Truck or car, any one of them will lose momentum, right? And one will gain momentum. Now, the amount of momentum which is lost by one object will be equal to the amount of momentum that will be gained by another object. Okay, so these are the points which you have to remember, that when two objects interact or collide with each other, there will be a change in the momentum, right? Now, what will be the change? One object will lose momentum and the other object will gain momentum. Now, the amount of momentum which is lost by one object, that will be equal to the amount of momentum which is gained by another object, right? So the law of conservation of momentum says that when two objects collide or when two objects interact with each other, the total momentum before the interaction, right, and the total momentum after the interaction is equal. Okay, so suppose the momentum of this object is means before interaction, suppose it is mu, right? You know what is m and u? Mass and multiplied by velocity, initial velocity. Similarly, this has also the same momentum, that is mass into velocity, but the velocities of two objects are different. They are colliding with each other, right? If I add the momentum of these two objects before interaction and when I add the two momentums after the interaction, they are found to be equal. So this is the law of conservation of momentum, and the statement I will tell you now, that when two objects collide with each other or interact with each other, the total momentum before the interaction and the total momentum after the interaction remains the same, provided no external unbalanced force acts on them. If there is any external force acting on them, then there will be a definitely a big change in the momentum of the two objects. But if there is no external unbalanced force acting on them, then the total momentum before and total momentum after the interaction will be same. This is what the law says. Okay, so suppose I take this object, right? I take object A and B. Okay, Now these two objects are colliding. Firstly, so they are moving in their own with their own speeds. Their speeds are different. Let us take this speed as u1 and this as u2. This is having mass m1 and this has a mass of m2. I am talking about any two objects. So I suppose the two objects to be A and B. Okay, A and B are moving in a straight line in the same direction. Okay, but the velocities are different. If suppose u1 is greater than u2, okay, if u1 is greater than u2, so definitely there will be one situation when they will collide. Okay, when they are colliding, then what will happen? They will exert force on each other. When they are colliding, A and B, when they are colliding, they will exert force on each other. So let this force be F1 and this force be F2. Okay, now if this is F1 and this is F2, A is exerting force on B, B is exerting force on A. So therefore these two forces will be in the opposite directions. Okay, because you can see the directions here, A exerting force on B, B exerting force on A. Okay, so this is the first part, this is the second part. Now what happens after interaction? After these two objects, when they interact, they do not remain in the same place. They both start moving in the same direction, either this or this, that depends on the situation. Okay, and the velocities also change. Masses will not change, velocities will change. So let this velocity be v1 and this will be v2. This was u1 u2 and this was v1 v2 and this is m1 and m2 respectively. Okay, so you are following two objects moving in the same straight line in the same direction. Masses are different, right? Velocities are different. So we assume that they collide with each other, right? When they collide with each other, what happens? They will exert force on each other. Okay. Now the momentum of this object is m1 u1. The momentum of this object is m2 u2. Okay. Now after interaction, what happens? m1 v1 and this interaction m2 v2. So according to the law of conservation of momentum, it says that the total momentum before the interaction and the total momentum after the interaction is constant or it remains conserved provided no external unbalanced force act on it. Okay, so if we have to write in the formula, that means we can write m1 u1 plus m2 u2 is equal to m1 v1 is equal plus m2 v2. Okay, so what is this? This is the total momentum of the two objects before the interaction. And what is m1 v1 plus m2 v2? This is the total momentum of the two objects after the interaction. Okay, so this law says that the two momentum before and after the interaction remains the same. No external unbalanced force is acting on them. Okay, and therefore the momentum remains conserved. Conserved means no change. Okay, so we have a big derivation of this particular law. Means it is given in the textbook. I will explain you that also. So today what you will do is you will read the chapter. That means this topic you will read. You will learn this law, and I will explain you the actual examples, means actual applications of the law of conservation of momentum, right? Suppose what happens, one car and one truck collides. Suppose two cars collide. Okay, then how will the change in momentum take place, and will the momentum before the interaction and will the momentum after the interaction remain same or not? How will we come to know? Okay, but before that you have to understand this law, that when two objects are colliding with each other or they are interacting with each other, the total momentum before and after the interaction remains constant or it remains conserved provided no external unbalanced force act on it. So today you will write this law in the notebook, you will listen to my explanation what I have explained you just now, and you will write this formula and the derivation also I will explain you. Then I will come up to the examples of this law. This will finish your chapter, children, and after this we are going to come up to the exercise questions. Okay, so learn everything what I have explained you till now, and if you have any doubt you can ask me. Okay, so today you will study what? Law of conservation of momentum, If you want to revise momentum, then you can go through your video or my video, go through your notebook. If you have any doubt, children, you can ask me. Okay? Thank you and have a nice day.